Suppose you work for a company that produces and sells energy drinks. The marketing team claims that the latest flavor, Electric Lemonade, is a hit with more than 50,000 consumers. It's believed that 60% of those who tried Electric Lemonade will buy it again. So, in other words, they have a population of 50,000. It's believed that 60% of those who tried electric will buy it again. So, this is kind of like our claims. That's probably our null hypothesis. You believe the actual percentage that would purchase Electric Lemonade a second time is greater than 60%. So that greater is going to be important. You randomly select 197 customers who have tried Electric Lemonade and ask them whether they'd buy it again. You find 134 of the 197 say they would buy it again. At an alpha of 0.01, can it be determined that more than 60% would purchase Electric Lemonade a second time? So I'm going to start off and kind of go out of order. I'm going to start off with my hypothesis. Well, my hypothesis is the initial claim that it was 60%. All right. My alternative was they said more than, so this is going to be greater than 0.60. All right. So what we're interested in is how many people are actually going to purchase Electric Lemonade. So let P equal the true population proportion of people who would purchase a second time, of people who would purchase Electric Lemonade a second time. All right. So we need to go ahead and do our conditions. The first one was they said we had a random sample of 197. Random sample of 197, and that was given. So we can check that off. We need to check the n is less than 10%. Well, n equals 197. We're going to multiply that by 10, 197 times 10, and that equals 1,970. But what was our population size? Our population of people who tried it was 50,000. So that's less than 50,000. So we're good there. All right. NP and N times 1 minus P. NP has to be greater than 10. So in this case, 197 times 0.60. What do we get? Well, let's check it out. 197 times 0.6 equals 118. And that's greater than 10, so that takes care of that one. And then we need to check n times 1 minus p. That also has to be greater than 10. So 197 times 1 minus 0.60. 197 times parenthesis 1 minus 0.60. And we close that. And we get 78.8. And that's also greater than 10, so we can check that off. All right, please note that when we're running a hypothesis test, we're using NP and N times 1 minus P. And that's consistent because our formula is Z equals P hat minus P. But look what we have. When we look at our denominator, it's P times 1 minus P over N. So the P and 1 minus P is what we have here versus the confidence interval. This will be a P hat. But that's in a radical on the confidence interval, it's also P hat. So please pay attention to what's in your radical. The conditions and this need to be the same. All right, what was our X? Well, we said that we had 134 of the 197, so that's our X. Our P, this P is easy, it's just 0.60. Now this is 134 over 197. Let's find out what that is. 134 divided by 197. Should have given myself a little more room. That's 68%. So this equals 0.6802. All right. So if I was going to graph that, here's what I would have. We're centered upon P, and this is 0.60, and that's our P. Our alternative was greater than, so we need to note that down. And this right here is 0.6802, and we're going to shade up. So we're going to plug in, and we have the probability that Z is greater than 0.6802, that's our P hat, minus our P of 0.60, all over 0.60, 1 minus 0.60, over our sample size of 197. Now we use the greater than symbol because that's what we had in our alternative. So let's go ahead and run this thing. So we're going to go stat test 1 proportion Z test, 0.6, 134 and 197, a greater than, and then we're going to press calculate. So we want the probability that Z is greater than 2.297. And that yields a p-value of 0.0107. So our p-value is 0.0107. And what was our alpha? Our alpha level is 0.01. Well, this is greater than, all right, because 107 is bigger than 100, so we're going to fail to reject. So our conclusion, our p-value is 0.0107. We fail to reject the hoe or the null. There is not sufficient evidence at alpha equal 0.01 to suggest, and now we need to restate our parameter, which is the true population proportion who would purchase electric lemonade a second time, to suggest that the true population proportion of those who would purchase electric lemonade a second time is what? We got to look at our alternative, greater than 60%. Kind of ran out of room there, but there you go. Appreciate you watching. I hope that made sense. So in this particular case, even though we ended up with a small p-value, it was still bigger than alpha, so we failed to reject. So there's not enough evidence to say that they'd purchase it more than 60% of the time. All right. Thank you for watching. Hope to see you on the next one.